Hi, welcome to my real-time operating system concepts videos. In this video, I have tried to simplify and demonstrate synchronization between interrupt service routine ISR and threads by using some simple and understandable examples. Let's start with this simple example. Consider an embedded system where when input is fed to the processing unit using an input device, which is keypad here, the embedded system processes and displays output on the output device. In this example, let's say when asterisk or a star button is pressed on the keypad, the environmental conditions are displayed on the screen, like humidity, atmospheric pressure, temperature, etc. It may be any kind of screen, LCD screen or LED screen. So with the help of this example, we will understand how interrupt service routines or ISRs and threads or the tasks can be synchronized using binary semaphores. As explained in my previous videos about types of semaphores supported in any real-time operating system, RTOS, let's make use of a non-mutex binary semaphore here for the purpose of synchronization. Okay, so now consider this piece of code. First of all, the main thread or the main task registers the interrupt for the input device, that is a keypad in this example. So any real-time operating system provides such an API or a function to register a hardware interrupt. We have talked about APIs also earlier, application programming interface, services provided by the real-time operating system. So this API takes first argument as hardware interrupt number, which you want to register, for which hardware you want to register. And another argument would be the function name or the interrupt service routine name, which we need to define. Let's see that later, or the ISR name. So this would be our ISR function name, which gets called when the hardware interrupt is triggered. Then next thing is, let's create a non-mutex binary semaphore with its initial state as not available. For the purpose of synchronization, it is important to create a non-mutex binary semaphore with its initial state as not available. And then we will create a thread whose task or whose function is to display the environmental parameters. Okay, and this is the entry point or function name of the thread. Okay, so this is the body of interrupt service routine ISR, which gets called when an interrupt is triggered, and this is the body of the thread. So this task or thread enters into execution, which is in an infinite while loop. So first thing it does is acquires the non-mutex binary semaphore, and note that which we have created this semaphore with its initial state as not available in the main thread. Since the semaphore was created with the state of not available, this thread gets into blocked state or a waiting state, which in other words, it is waiting for an interrupt to trigger, requesting for the display of environmental conditions. So thread is waiting at this point, it is blocked. Now let's say the button is pressed, the star button is pressed on the keypad. So when a button is pressed, an interrupt is triggered. So as soon as the interrupt is triggered, ISR gets called, which releases the semaphore. ISR releases the binary semaphore by calling an RTOS API semaphore release. Now watch the state of semaphore. It becomes 1, means available. So as soon as semaphore is available, the thread which was waiting for this semaphore gets unblocked. So once ISR is completed, the thread starts executing from this point, from the point where it was blocked, and from here it performs the instructions to display the environmental data. So in summary, when a key is pressed, hardware interrupt is triggered, which calls an ISR. An ISR is signaling the thread, and the thread does what is required. So ISR is signaling the thread with the help of a binary semaphore. So binary semaphore, non-mutex binary semaphore, is acting like a signaling mechanism. And once this thread completes the task of displaying the environmental data, it loops back and again tries to acquire the semaphore, which is not available because this thread was able to successfully acquire the semaphore when it was unblocked initially. So it again gets into block state, waiting for the star key to be pressed again, and ISR release the semaphore. Well, now you may have a question that when the button is pressed or when an interrupt is triggered, interrupt service routine or ISR gets called, and ISR signals the thread to perform particular task, like in this example, displaying of some environmental parameters. So thread performs this task, but why not the ISR itself performs this task of displaying environmental parameters? So the answer is simple. ISR has to be as small as possible in an RTOS, just to respond to the external hardware request, that's all. Because when an hardware interrupt is being serviced, all other interrupts are disabled. The RTOS scheduler is disabled, and all the current processing is like halted by the CPU to service the interrupts. That is the reason why an ISR should be as short as possible and offload the actual work to the threads, right? So please watch my another RTOS logics video where I have dedicatedly explained about an interrupt service routine, like how an ISR should be returned in an RTOS. Okay, so yeah, that's all for now. In my next video, I have demonstrated synchronization between ISR and multiple threads and inter-thread communication. Please watch and subscribe to my channel. Thank you. Thanks for watching.